Good afternoon, everyone, and welcome to Jigyasa Analytics webinar, Getting Credit Scorecard Right, the Art and Science of Segmentation. My name is Krishna Mehta, and I will be taking you through the presentation today. A little bit about us. We are a data science company based out of New Jersey, USA, with global delivery capabilities. We help organizations make better decisions with the help of data science, machine learning, and AI. And we serve organizations in financial services, publishing, nonprofits, as well as retail. Here are some brands which have associated with us in the past. So, the first question that we need to answer is, why do we need segmentation? And we need segmentation because of many reasons. The first thing is consumers and businesses are heterogeneous. And so the same model, the same scorecard might not be relevant for everyone. The next thing is that the business itself might be organized a little differently. There might be different divisions, units, different products might be handled differently by the lender. All of this means that they probably need to be treated differently. And then the third thing is data constraints. We might have greater data for certain products, lending products, whereas we might not have that much data for other lending products. There might be certain segments of businesses or consumers for whom we have more data than others. So, because of these reasons, we often think it is a good idea to segment the customer base. So, if you implement a good segmentation scheme, what should you expect? You should expect an improvement in your model performance. Again, it varies from organization and product and everything, but we have, across the board seen at least 5 to 10% improvement in model performance because of a good segmentation scheme. Now think of what that means, that 5 to 10% improvement means for the performance of your scorecard. It's a significant improvement. And then another reason to do this is that the business will be better aligned, the actual lenders, the credit officers will be better aligned, and so there will be greater adoption of this scorecard. Let me talk to you a little bit about some of the common approaches to segmentation currently being used by organizations. The most popular approach probably is business driven. In this approach, the segmentation is driven by either products or business units. And the advantage of this approach is that business finds it very intuitive, they're already aligned with it. And from a decision making perspective, too, things are aligned by business units, so decision making becomes a lot simpler. And then there is algorithm driven segmentation. In this approach, basically, data science techniques, machine learning techniques, or AI techniques are used to derive the segments. And the advantage of this approach is that it is most optimal from a model performance perspective. It is tuned to get the most performance out of the model and the scorecard. And then there is data availability segmentation. Now, for building a credit risk scorecard, we use data from multiple sources: bureau, firmographic, demographic data, all of that. So, what that means is that if since there are so many different data components, an applicant might have some of these data feeds missing for them. And so a natural way to segment would be by data availability. Now, the advantage of using a data availability segmentation is that you do not need to derive data and guess its missing value for where it is missing. Before I get into details of segmentation schemes, I wanted to take a moment to also introduce the concept of supervised versus unsupervised clusters. So, what do we mean by unsupervised? For unsupervised clustering, basically there is no objective. The algorithm is just looking at the general patterns in the data and identifying natural clusters in the data. So that's unsupervised. For supervised, then, there is a goal, an objective. For example, if we are building the credit risk scorecard and we are interested in default, then the goal is, or the goal of the clustering exercise for supervise would be to find patterns which are relevant for default. So, a natural question to ask at this stage is, why do we need both supervised and unsupervised clusters? And look, the unsupervised clustering is giving you kind of the lay of the land. It's telling you all the natural segments that are available in the data. Now, by doing this, it's giving you a big pool, and then the supervised clustering is able to focus your attention to the task at hand and giving you some or validating some of these segments as being relevant for the task you want to do. But knowing that bigger pool is very helpful because a lot of times there might be some underlying conditions which might otherwise be missed. You get a greater understanding of the data, and if you consider some of these segments, you might end up building a more stable system of scorecards. So that is why you it's good to look at both unsupervised and supervised clusters when developing your credit risk score. So we talked about business segmentation, we talked about algorithmic segmentation, and we talked about data driven segmentation. Each approach of segmentation has its merits, and our recommendation, and from experience, what works best is to engage stakeholders to produce the final segmentation, which is often a hybrid approach which combines elements from each of these different approaches and creates the final approach. And what we will do is we will now take you through one way of developing this hybrid segmentation system. Here is how a hybrid approach to segmentation would work. Mm, As a first step, shortlist segmentation variables, and we'll share some greater thoughts on this as well. Then perform unsupervised clustering. After that, perform supervised clustering. Then get business operational overview on the clusters, and based on that, develop the final segments. And we will talk about each of these components a little bit next. So the first thing I want to talk to you about is how do we shortlist the segmentation fields. See, your scorecard building data set is going to have hundreds and hundreds of fields, and using all of them for segmentation could become very chaotic and very hard to implement. And because of that, it is a good idea to bring down that set of fields to be considered. And you know, this is where we take multiple approaches. Okay. We look at the data and see, okay, there are certain fields, data components which have which are missing, for example, for certain set of customers and so on. So we take those data availability fields as candidates. We might run some exploratory data analysis based on the data. Based on that, we say, okay, for the problem at hand, these different fields, these set of fields might be relevant, and we include them as segmentation fields. And then the business might have certain inputs. There are some natural business segments where they do business, products, so on. So we consider all this set across different approaches as our starting pool for segmentation. Because look, it is very unlikely to have more than 7 8 segments for your scorecard. Having more than that, significantly more than that, will make your entire credit scoring process very cumbersome and hard to implement. Now, if you have, and so you don't need to start with hundreds and hundreds of candidates for segmentation, but you need to carefully uh, find the fields that are relevant, and that is what we are kind of proposing here. So let us start by unsupervised segmentation or clustering. And what we are doing here in our approach is, first we do principal component analysis. We follow that up with canonical discriminant analysis. And then finally, we do k-means clustering. The reason for doing these different approaches is something we will go into in greater details on the next few slides. But at the high level, uh, principal component analysis kind of gives you an overview of what whether your data needs segmentation or not. And then canonical discriminant analysis run at different important fields level tells you whether segments exist for them, or whether interactions of them lead to segments. And then k-means is another approach to kind of validate what you find from your canonical discriminant analysis. So I mentioned that in our unsupervised clustering approach, the first thing we are doing is principal component analysis. So principal component analysis is a way where you use correlated fields in a data set to create a new set of fields which are not correlated to each other. So say your data set has 10 fields, and like they will be somewhat correlated to each other. Income, time in business might be correlated, for example. And what principal component analysis does is it creates a new set of fields. These are all orthogonal to each other and not correlated at all. Now, without getting into the math of principal component analysis, the advantage of having these independent fields is that when if you now then take the two main principal components, for example, and plot against them, and these are not correlated anymore, but if you still see grouping of data, these must be natural clusters. So in this example, for you see one cluster, a second cluster, a third cluster. So it's just kind of a good way to test if your data has clustering in there and whether the segmentation exercise is worth it or not. So what we have done till now is we have identified a set of predictors or uh, fields of interest for segmentation, and then run some principal components with them to confirm that our data does have natural segments. The next thing we'll do is canonical discriminant analysis. What canonical discriminant analysis is a statistical technique. It creates a linear combination of these of these different fields, And this linear combinations, the unique thing about that is that it is developed to maximize the natural segments that occur in the data. It's a semi-supervised technique because we are using some intelligence about our problems at hand to kind of feed the data into this, as we did in the first step. But it identifies the cluster independent of a target. So in that sense, it is unsupervised. Now, it gives us a linear combination of the fields, and multiple of them, and we can then plot them against each other, and the segments appear to us. Each of these segments will have certain properties in terms of the different predictors and values, and using that, we can create segments in our data. So we now have using all the steps we have done till now, a potential set of segments. Next, what we would like to do is kind of validate these segments. And the approach we take is using k-means clustering. Uh, what k-means clustering is, it assigns observations to k clusters based on distance measured from the centroid of each of the clusters. It is an unsupervised technique. It identifies the cluster independent of a target, and that is why it is unsupervised. And the the number of clusters has to be specified here, and it assumes certain parametric constraints which we'll not get into right now. So the way we determine the number of clusters is, there are certain metrics. Whenever say you say, I'll give me a 2 cluster solution, 3 cluster solution, 4 cluster solution, and like there is this metric CCC, and there are some other metrics also which are often used like pseudo f. But for CCC, for example, what you see is that at 4 clusters the CCC is maximum. So that tells us that maybe 4 clusters is the right clustering solution to get. And then for each of those clusters, like for the 4 clusters, you will get certain characteristic, okay, in terms of profile, maybe in terms of data availability, in terms of time in business, in terms of business segment they are coming from, all these different um, segments. You will each cluster will have a certain characteristic, and you've got a certain set of clusters based on your canonical distribution, and you can see whether the clusters you got there kind of resonate in terms of the distribution and so on from what you've got in k-means, and that can be a validation of your clustering approach. The next thing we do is take the set of clusters we have obtained from our unsupervised or semi-supervised approach, and now run it through a supervised technique. The supervised technique we uses default as a target variable, and we use a tree-based algorithm called cart for this. So what this tree does is, it divides the data into different nodes, and by looking at these divisions, we can understand if some of the segmentation we were doing with some of the fields are relevant for our cart node or not. If they are not, we are telling us probably for this problem at hand, maybe segmentation on by that field is not that important. And what this exercise is trying to do is trying to zero in on relevant segmentation. So all these steps I am talking about, all these process, uh, none of them are absolutely necessary. You can form your segmentation scheme in different ways, but following this approach of creating the flow of supervised techniques, or rather unsupervised techniques, and then the supervised technique, you are getting greater confidence on the segments you will finally land up with, and you are able to hone in on what is relevant for your task at hand. So now, using all these steps, you have obtained your set of segments. Next thing you do is incorporate business refinements. When you present the segments to the business stakeholders, they might have a perspective that, hey, splitting on this field in segmentation makes our life very complicated, because we have the business practice of keeping everyone with this way on this field together for whatever business practice reasons. And because of that, you might go back and refine your segments based on that. So that's kind of the business refinement. And then there might be legal refinement as well, especially for banks, where legal might weigh in and say, hey, this is not acceptable from fair lending, for example. And because of that, there might be additional refinements needed in the process. And then there are operational refinements. The IT team might come back and say that, hey, this field is you have used in segmentation is going to be retired because we are moving away from a legacy database, or this field is available for model development, but it might not be available in the production system, or it might, or to get this just this single field, we have to subscribe to this additional database, and it will be that much more expensive. Based on that, you go back to your segmentation and might do some additional tweaks. So all of this end user uh, of the scorecards, feedback, the legal feedback, the business feedback, all of this incorporates, and then you make the final segments. I hope you found this presentation useful. Thank you so much for making the time today to join us for this webinar. We have many more of these webinars coming up on different topics. So please keep checking our Eventbrite page, and hope to see you again for a future presentation. Have a wonderful day.